Okay, welcome to this video on the 2017 higher level question C1. So the accompanying map located on the back page of section A shows ground contours at 5 meter vertical intervals on a proposed ski run. On the map, A, B, C, D is the center line of the ski run. The ski run has the following specifications. The portion of the ski run between A and B is level at an altitude of 65 meters. The portion of the ski run from B to C is falling uniformly to a level of 50 meters at C. The portion of the ski run from C to D is level at an altitude of 50 meters and is widened on its northern side as shown. Okay, on its northern side is shown. Using side slopes 1 and 1.5 for the cuttings and 1 and 2 for embankments, complete this earthworks necessary for the ski run between A and D on the northern side. You may ignore the southern side. You may ignore this down here. Okay. What you need to do is check what are the contours rising in. 5 meter vertical intervals. That's important. What's the scale? 1 is to 1,000. So 1 meter in real life equals 1,000 millimeters. 5 meters, okay, equals 5,000 millimeters. Okay, so the scale is 1 is to 1,000. So for every 1 unit you see on your sheet in real life, there's 1,000. Okay, so divide this by 1,000. You get 1 meter equals 1 millimeter. So 1 meter in real life equals 1 millimeter on our sheet. 5 meters in real life equals 5 millimeters on our sheet. Because for every 1 unit in real life, or for every 1 unit on our sheet, there's 1,000 in real life. Okay, now, remember the ratio for cuts is 1 in 1.5. This area from A to B, how do I know what this is? I know it's level at altitude 65. Is it a cut or an embankment? I want you to think about it. It is an embankment. Or sorry, cut. Why? Because the numbers are above 65. Okay, the ratio is 1 is to 1.5. So for every 5 units you go up in real life, we're going out 7.5 units. Okay, so 7.5. So I'm marking lines every 7.5 here. Right, so there's my cut lines, alright. The road is at 65, the next one is 70, 75, 80, 85, 90, 95. So the road rises the numbers rise in numerical value for cuts, okay, the further you go out from the road. In embankments, the numbers get lower in numerical value the further you go out from the road. So 70, okay, 75, okay, 80, 85, 90, 90, and then I'm going to do another 85 there. So even though it doesn't go past B, the reason I done those points there is because this cut here is going to intersect with the next section of earthworks there. So I'm going to sketch these together. So stop being heavy just about there, and then nice and light over here. Okay, and we have A to B done. Now we're ready to do B to C. Now remember, it says the road falls the portion from B to C is falling uniformly to a level at 50 meters at C. So point C is at 50 meters. Point B is at 65 meters. So if you imagine this is the ski slope. So B is at 55, B is at 65, and C is at 50. Okay, now that's not its real slope. Its real slope would be something like that, a little bit more gentler. Now, how do you figure out if this is an embankment or a cut? Well, the numbers here are higher than the 65 here. So this is a cut, okay, and all these numbers here are higher than the lowest point on the road, higher than the lowest point on the road. So this is a cut on a falling road. So for cuts, your fill cones or your cut cones go at the lower end of the road. So our cone is going to go here. And the question is, how do you figure out what the radius of the cone is? Well, here's the portion of the road. So 65, or the ski slope, 65, 50. The base of the cone is always level with the highest point you're using. You got to figure out the difference in altitude. The difference in altitude is 15. Okay, so the base is at 65, the apex is at 50. 65 minus 50 is 15. The ratio for cuts is 1 into 1.5. So 15 multiplied by 1.5 gets me 22.5. Okay, that's how I work it out. So the radius of my cut cone is going to be 22.5 millimeters. So I'll set it there. I'm going to get my compass. And I'm going to draw this here. Right now. Then what we're going to do is take our set square, join B to the cone, and we'll draw it in tangential. Alright, you don't need to go through the actual method of drawing a line tangential to a circle. Okay, you don't have time. Okay, all our cut lines are going to be parallel to that edge then. Okay, and they're all going to be 7.5 apart. So 7.5. And down here as well. And we'll need to go down here as well. Okay, so they're all 7.5. I've done them. Okay, now. So we're going to draw lines parallel through those points. Okay. Oh, nice and far now. And down here. Okay, now, the base of the cone, or the curve on the cone, alright, even though the cone is upside down, the base is always level with the highest point, or the point you're using. For an embankment, the apex is at this apex is at the highest point, and the base is at the lowest point, but we're doing a cut. So, this is 65, this is 60, and this is 55. Over here we have 70, 75, 80, 85, 90, and 95. So for 55, this is our 55 here. Okay, and there's going to be a point there. 60, 65, 70, 75, 80, 85, 90, and then 85 again. So we're going back down to 85. And then we're going to sketch all those points in. So you're going to see what I mean now by the intersection. I'm going to sketch them in. Okay, and where they intersect here, okay, is the point at which you join there to B, because that's where it goes from being a level cut for a level road to a cut for an inclined road, so a falling road. Okay, so don't forget your tadpoles, just one out for each. Don't be spending any more time with them. Now, this area of the road, or the ski slope, is level at 50 meters. Okay, and the numbers here are lower than the widened area. So, it's an embankment. Now, if you check your sheet now, what are the distance of the lines going to be apart now? They're going to be 10 millimeters because it says 1 and 2 for embankment. So for every 1 unit you go down in height, you're going out 2 units. So if I drop down 5 meters in height, I'm moving out 10 meters. Okay, my earthwork line is at 10 meters out from the road edge. Okay, so this is 50. 45, 40, 35, 30. And I'm going to draw in lines parallel to the edge of the ski slope there. Okay, I'll probably need this 30 to go on a bit further, because it'll intersect with a portion of it. Right, now, so that's at 50, 45 is here. 40 is there. 35 is there. 30 is there. So I'm going to join them up. I'm going to heavy to about there, and then I'm going to go lighter with them because they're going to intersect with this area. Now we're going to apply the same idea over here. Our lines are going to be parallel to the edge of this road. So every 10 apart. Now, 50, 45, 40, 35, 30. As I said, the numbers drop in numerical value for embankments the further out you road, further out you go. So 45, 40, 35, 30, 30, 35, 40. So we're going to sketch these in here. Okay, and the two earthworks for both sections intersect here. We're going to join these together, and then we can heavy in our earthworks. Okay, now The next thing we're going to do now is we put in our tadpoles. They go for an embankment. They go towards the road. Now, this is a tricky enough one, okay, if you don't read it carefully. In the space provided at the top of the map, draw the vertical section profile through the ski run on the line E to F. Now, the line E to F is in the middle of the run. Alright, so loads of students will be expecting this vertical section profile to be this curved shape like past ones. It's just a portion of it is going to be flat, slanted, and straight again. So I'll just give you a quick sketch. Like that. That's what it is, because there's a person, ski, down, flat. Alright, that's its profile line. Through the run on the line ski to F. Vertical towers constructed at points E and F support a steel cable for a ski lift. The cable is 15 and 20 meters above the ground at points E and F respectively. Determine the maximum vertical distance between the cable and the ground. Assume that the cable is a straight line. Right. E is in between line A to B. So E lies in a flat area. And F is in between the line C to D. So F is in a flat area here. Right. So I'm going to bring C up to here. This is point C. So I'm going to heavy this in there. Right. I'm going to bring B up. I'm going to bring A up just to make my life easy. I'm going to bring E up. And then we'll bring F up. Now, B is an altitude of 65. So I'm at B now. That's 55, 60, 65. So this is point B. And A to B is straight. So I'm going to bring that straight back there. That's A. And B joins to C. So this is the profile of the ski run. But bearing in mind now we're looking for the ski lift. So I'm going to get a pen here and do this in pen. Okay, so it said E is at a height of 15 meters from the ground. So we're going to measure up 15 millimeters right up from point E, okay, from line AB. So there's point E. Okay, now F is 20 meters above the ground. So we go over to point F and we measure up 20 from point F. So here's F. Now we're going to join E to F. Alright? And the question says is, what is the maximum vertical distance between the cable and the ground? Alright, so the maximum vertical distance between the cable and the ground, right, look, all this small area, it gets wider and wider until the ground, until this section here, from point C up, is the highest vertical distance. You can see it. You can see it there. This is the point at which it's the maximum gap between, the maximum gap all along here is right there. You can see it. Okay? So you draw in your line. and then you measure it, and I believe it is 22, okay, or 21, okay, so 21, what do we have? Determine the maximum height, so 21 meters vertical distance. Okay, now if it's 22 or 20, I don't think you'd lose many marks. Alright, now if it was 32, you would. You've done something wrong. Next part of the question. On the map, P and Q are 2 points on the surface of the Earth. So P and Q are 2 points on the surface of the Earth. Vertical boreholes at these points reveal the top surface of stratum at altitudes of 50 meters and 35 meters. Okay. A skew borehole at Q is drilled in an easterly direction and has an inclination of 55 degrees to the horizontal plane. 55 degrees to the horizontal plane. It reveals the top surface of the stratum at an altitude of 30 meters. In the space provided at the top of the map, draw the elevation of this triangular portion. So draw the elevation of this triangular portion of the top surface of the stratum. Draw the plan of the triangle and determine the strike and dip of the stratum. Okay. Key principle. The true length of a line, TL for true length of a line, is seen in a view when, seen in a view when the line, wrong principle there. Okay, I was writing the wrong one. The true angle, rather, between a line and a plane is seen, alright, I'm leaving out seen, when the line is the true length and the plane is an edge. Okay. So the line is a true length and the plane is an edge, right? So go back over that. P. Okay. Point P. We're going straight up from point P. Okay. Vertical boreholes from point B. P reveals the top surface of a stratum of ore at 50 meters respectively. So this is point P, and Q at 35. So line straight up from Q and drop down 15, okay, from that line given to you, because that brings you to 35. So this is Q. Alright? Now, to get the other one, a skew borehole, okay, is drilled in an easterly direction, okay, and has an actual inclination of 35, or actual inclination of 55. So this would be the skew borehole in plan. Okay, in this direction. Okay, easterly direction. And has an actual inclination of 55 degrees, 55 degrees to the horizontal plane, and it reveals a stratum at an altitude of 30 meters. Now, so Q, this is where, see, this point Q is where the drill hits the surface, but the start of Q is at 90, because it's on the contour 90. So I'm going to measure up another 40 here. So this is the start of Q, and the angle is 55. Okay, so you're going to get your compass there, or not your compass, your protractor. I sound like one of the students now, mixing it up. No disrespect. Right, and we're going to draw a line. Okay, wherever we want, or we'll do a construction line. $55. Sliding set squares now over to your actual start point. Okay, over to here. And along this line, once it hits altitude, 30 meters, so P is at 50, Q is at 35. So down 5. Straight over. So once it intersects that line there, we're going to have our point in question. So this is our point. I'm going to call it A. So P joins to Q. Okay. Q joins to A. Oh shucks, sorry. Q is there. That's where it is. Q joins to A. A joins to P. Now point A is drilled in an easterly direction, so it's on this line straight across from Q. A. Q joins to P. And A to P. And A joins to Q. Right, now we've determined the strike and dip of that triangular surface. So in order to do that, we need to see that triangular surface as just a line. So what I'm going to do from point Q is I'm just going to draw a line straight across. Okay, so you can think of it as this line is parallel to an XY line. So if a line is parallel to XY line elevation, it's a true length in plan. Its point number 1 is on line P to A. Our elevation. So I'm going to drop it to P to A here. There's number 1. Alright, so I'm going to join Q to 1. And this is the strike. It's the true length. TL. Okay, I'm going to change color pen. Okay, avoid pen yourselves. So you project these 4 points parallel to line Q1 from plan. Okay. So here are your projection lines. Your X1, Y1 line is perpendicular to your strike. It can be anywhere after that line. X1, Y1. Okay. Now, we can mark the heights along here. So we know P has an altitude of 50 meters. Q has an altitude of 35 and A is an altitude of 30. So you can start now. You could measure 90. You could mark every 5 up to 90 if you wanted here. But that'd take a while. Alright, so what we could do is just pretend we're starting at, we'll say here 25. So 25, 30, 35, 40, 45, 50, and 60 would be my last one, even though I don't need 60. Alright, so once we have them marked in, we're going to draw lines parallel to the X1, Y1 line. So I'll zoom in here. So these are all parallel to the x1, y1 line. I'm using sliding set squares. So if you don't know how to do that, hold one line up. Okay, I would have shown you, I'm sure I showed you before, but I'll put another video up of it. So x1, one set square up with the line x1, y1 line that my finger is on now here. But the other one, as you can see right here, coming on your top left of your screen, in against it. So this is my right hand here. Hold the other one with your left hand, slide the one with your right hand there, and that does parallel lines. If you want to do perpendicular lines, you could go then just put it here, and I do perpendicular lines. Okie doke. Right, now, so P is at 50. So, sorry, that's 55. So P is at 50. There's P. Q is at 35, so we bring Q to 35. And A is at 30. So there's A. Now I'll zoom back in again. Now, join all those points together to form one straight line. And this is your dip. The angle between them, the angle the surface makes to the horizontal plane, okay, is the dip. Alright, HP. So, to check this, you should always measure the angle of it. Alright, so the angle is 34 degrees. Okay, dip. If you don't measure the angle, you risk losing up to 8 marks. Right, that's the question done underneath the time limit of 35 minutes. So cheers, thank you, bye bye.